All right, we are in week 8. We'll be going into tidal power here in a little while. We're going to start off with 511 Economics of Hydroelectricity. And what do we get coming up this week? Assignment 3 or problem set 3. And then a reminder on the summary 3 up here from week 7. You guys need to be collecting your data every 2 days, every 48 hours or whatever. Whatever your timing is. You need 6 data sets. Or I'm sorry, you need 3 data sets, 2 days apart. And get those into Excel so you're ready to start working with them and working out all your charts from those. So by now you should be towards the end of that. If you're not, you better get started on it today. What you got?
I think we're on problem set 2.
Problem set 2?
Yeah.
Okay. Yeah, that's right, because you guys were just sending me on problem set 1. So yeah, problem set 2 up here from weeks 5 and 6. That's what you guys are up to. Okay, that's fine. And there is a place to submit it. Was it this guy? Was it you guys, or was it the other class? Was it 101 that was missing the submit? Okay. Actually, I think you both were. I put one in there this Sunday night, I guess it was, because I know I saw an email from Levi.
Yeah.
Couldn't remember if that was 101 or 102, though.
That was 101.
Okay. All right, so you guys are working on problem set 2, and this week Brad's out of town. Well, like I said, we'll finish up hydroelectricity today and get started a little bit into Chapter 6 Tidal. The exam's not till next week, so we'll take our time with it. There's no big rush. As you're getting to this now, like I said, you should have your data for summary 3. Go back to review Brad's lecture up here, lecture 14 on the Excel for doing your spreadsheet. That'll help you a lot to watch. It's a lot to absorb all at once, but if you watch him do it over again, that'll help you a lot with your numbers. All right. Any other issues? Anything come up that you guys any questions with last week's stuff on hydroelectricity or anything? All right, let's jump right into 511, then the economics of hydroelectricity. So how are we looking at capital costs? What kind of stuff are we looking at? Maybe before we get to that capital cost. Say I wanted to go build a hydroelectricity plant in the Rattlesnake. We got the creek coming down there, but I know that if we dammed it off right there, just north of I-90, and filled the whole valley, we could put a heck of a hydroelectric dam in there, right? What kind of problems would we run into if we go down there and start piling up rocks in the creek? Because we can look at this at that scale and see that it's actually no different than building another Hoover Dam. So what happens if I go up there and start damming up that creek and gonna flood out homes? So that's gonna have some people upset. Wildlife, because everybody likes going up to the Rattlesnake to hike, right? We're gonna flood that out because everything up there, Brad's house is going to be under 200 feet of water ideally to, get enough head to generate the electricity that we want to generate. So we're going to fill that whole valley. So there might be some environmental concerns. There are definitely some social concerns. There would be a lot of residents up there that are not very happy that you're going to flood out their house. What other issues would you be looking at?
I mean, you're going to shut down a lot of businesses and everything, so people have to not only relocate, but they got to find new ways of financial means.
Right. So it's kind of so it's an economic. You're going to close a lot of businesses. Those people are all going to have to move out of their houses. You're going to create some new businesses because now, guess what? Out by the airport, we're going to start building a bunch of houses for people who want to stay. But yeah, we're losing jobs. How about safety? Were there any safety concerns about building a dam across the canyon right there? And what would you think the safety concern might be?
People,
Yeah, you're still with the people issue because there are people involved.
got power lines and stuff like that.
Yeah, you're gonna have to add some infrastructure. But if I fill the Rattlesnake Valley 300 feet deep with water, what do I have to make really sure about for that dam?
Doesn't fail.
That doesn't fail. Because if that dam fails, what's it pointed at? Kind of like right at Grizz Stadium and the whole university, and it's kind of like looking down the barrel of a cannon, right? And typically you don't see reservoirs built above a town like that, just for that very reason. History is a pretty good indicator that that's not a good idea. So before we even get into economics, how is that? Do you think that would be feasible? That we really, really, really needed electricity? Do you think filling the rattlesnake with water would ever fly? No, it's not going to happen. Even any of these lesser canyons around here, even if it's a place that doesn't even have a resident, in that entire valley, that entire canyon, if you go to put up a dam there, you are going to have Greenpeace all over you for the environmental aspects of it. You're going to have society all over you because that's taking away land use from other options. Now, we've seen that in the past, and you look at a lot of these reservoirs, they have small towns under them that 100 years ago they said, yeah, it kind of sucks that you live here, but pack up your stuff and move because we're building a dam here. And a lot of these reservoirs have small towns under them just for that very reason. So it used to happen and not so much anymore. That's one of the reasons why you don't see any expansion of hydroelectricity in the United States. It's very, very difficult to do. This doesn't happen. So when we talk about capital costs, what kind of capital costs are you talking about with hydroelectricity? What comes to mind? First off, what are capital costs?
It's money and cost to build and maintain it.
Yeah. Capital costs are all the equipment, the engineering, the construction, everything is invested before the first kilowatt of electricity comes out. And to dam up the rattlesnake, you'd probably have pretty good capital costs right off the bat just to build a dam 300 feet high across the opening to the Rattlesnake Valley. Would be hundreds of millions of dollars just building the dam. Then you got to put in the power plant. Then you got to put in the turbines. All these different things that you need to upgrade. It says in here in the book, your machinery is probably 25 to 50 years before it's going to need replacement. But really, in the cost of, if you looked at building a hydroelectric dam there, how much of a percentage do you think the actual equipment would cost compared to the cost of building the dam and the other infrastructure that goes along with it? The cost of equipment would be pretty small in comparison to what it would cost to build a dam. That's probably your biggest factor there. And let's pretend like there's not anybody in Rattlesnake, so you're not paying property values to buy all those people's houses out and everything. Just assume it's empty. The dam is still going to be the big cost of it. Then you're going to have your equipment. The structures like 50 to 100 year lifespan. All those go into figuring out whether or not it's cost effective, or whether or not should I build a dam here. What's our measuring stick for the value of a dam, whether or not it's worth it to do? How would you figure that?
Just like the total wattage, really, I guess the total energy.
Yeah, the total energy you expect to get. and how much is it going to cost me. So if it's going to cost, we'll use nice easy round numbers. If it's going to cost me $1 billion to build this dam, and how many kilowatts of electricity am I going to get out of it? Well, and actually, you're talking obviously, much bigger than you're talking megawatts, gigawatts, terawatts, and divide that out and figure out how much it's going to cost per kilowatt hour to build this thing, and whether or not it's worth it. If you look down in the unit cost, it talks about if you look at these places with potential hydro capacity of 1 to 1,300 megawatts, to build one, it was in the range of $2,000 to $4,000 per kilowatt. So it's probably even more than that now. 2003 was when they looked at that. And that's done on page 228. So if it's going to cost me, kilowatts are not a very big measure. So over the lifetime of this, how many kilowatts do I have to make at 10 cents per kilowatt to make up $4,000 per kilowatt? Quite a few, right? That thing needs to be running for a long time in order to recoup that cost. But that's how you figure it. What's the advantage of once I build this hydroelectric dam, though? What's the advantage about my power coming out of there?
Doesn't generate emissions.
No emissions.
No.
There's really no additional costs, right? I mean, I build it. Yeah, I'm going to have to do some maintenance on it, and it's going to need some new turbine blades once in a while and stuff like that. We figure in those costs. Those are fairly marginal. But I'm not putting any fuel in it, right? The fuel is coming from Mother Nature. It's coming from the rain falling out of the sky and snow falling out of the sky. That's my fuel. Maintenance costs, there's really very few moving parts. You build the dam structure. Yeah, you're going to have engineers look at it every couple of years and make sure it's doing what it's supposed to, but it's just a big pile of rock, concrete, stuff like that, and it just sits there. It's static, and it doesn't really do anything. There's no moving parts. Same way with all your plumbing. It's pretty much all static and not really anything to wear or have any issues with. So our moving parts are really the only issue. How many people, when you look at one of these big hydroelectric plants, how many people do you think are actually there on site running the show, making that happen? 1, 2? There's probably one person there with a bunch of computer monitors, just keeping an eye on things and watching for alarms. There might be one maintenance person, but they're not necessarily actively working on something. They're there just in case something happens. So manpower-wise, I can have a hydroelectric dam that's powering the entire city of Missoula with 1 employee or 2 employees. So it's very low cost once it's up and running. That's your low operation cost. Maintenance, again, the materials, it's good for 25 or 50 years for that turbine. There's really very little for you to do with it. So box 511 kind of does a comparison of combined cycle gas turbine and a hydroelectric plant. They're kind of the opposite. When you look at the cost, it's almost 3 times as expensive to build a hydroelectric plant, but it lasts almost 3 times as long. I don't know if I agree with the capacity factor. I guess it kind of depends on the location and where you're at and how it's done, how it's set up. Hopefully you'd have an average capacity factor a little bit higher than 50% for hydro, but okay, we can do that. If you look, operation and maintenance cost per kilowatt hour is a little bit higher for hydro.
It's less frequent.
Yeah, but it's much less frequent. There's the big one, fuel cost per kilowatt hour output. There is no cost. So basically, you're only looking at your initial capital costs are the only real expenses going in there, plus, your half a dozen employees that are there every day keeping an eye on things. So there is no fuel cost. So the average annual output shows the hydro plant putting out less. Again, it's because of that average capacity factor running at a lower level. When you start looking at the math, again, I don't necessarily agree with the numbers. They're kind of a little bit screwy, but you can see if we're getting into the accounting part of things now. But if you have a fairly low interest rate on it, hydro wins out every time. As the interest rate goes up, why do you suppose the cost per kilowatt hour goes up? Because that initial capital cost is 3 times the cost of the combined cycle gas turbine. So that's why the numbers, it all depends on how it's financed, really. But you can see all things being equal, and they're both financed at the same rate. Hydroelectricity is much cheaper in the long run, and especially because the lifespan is so much longer. It's pretty typical that they're going to be upgraded, but if you look at how old are a lot of our hydroelectric dams around here, if you think of the big major ones, think of the Hoover Dam, Grand Coulee Dam, when were those built? Any idea?
Pretty old. I mean, was it constructed in like the 50s?
Even older than that, 30s? Yeah, in the 1930s. So technically, they should be kind of the end of their lifespan, but not really. They did good construction, pretty sound engineering on them. So we're at that point where we're upgrading, refurbishing. Obviously, the technology's changed a little bit since 1930. So probably getting a little more efficiency out of them, probably a better lifespan, all kinds of stuff on the equipment. So they need to upgrade it, but as far as I've heard, as far as I know, there's not any immediate plans to close down any of those. They're all doing fine structurally, and it's just a matter of upgrading equipment. And obviously, if you expand that lifespan past 80 years or 60 years, it was listed there in the chart, the prices are only going to go down. This is part of the one that I find interesting. 512, the future prospects. So we know hydropower works. We've used it very effectively here. What do you think our future is for it in the United States? Let's look at not just worldwide. Just look at the United States. What do you think the odds are of another major hydroelectric dam going in somewhere anytime soon?
It's probably unlikely. There's not many suitable sites left. Take that long, upset somebody.
Yeah, I agree. There's not a lot of suitable sites that geologically there are plenty of sites. Environmentally, there are plenty of sites. Socially, there really are none. Even if you wanted to go do a small one on Rattlesnake Creek, clear up at the headwaters, away from town, and even then it would be not even taking any water out. We're not even talking about building a dam or anything. We're talking about simply capture, running a water wheel, and dumping it right back into the creek. You'd be pretty hard pressed to get that to pass. You'll see that you can live on the Bitterroot River, and there's all kinds of capacity going past you every day. But to even think about putting a small paddle wheel out in front of your house in that river, you would have several environmental agencies all over you pretty much instantly, just because that's not going to fly. They're not going to let you mess with the rivers. Some of it has to do with water rights. Some of it has to do with environmental laws.
So this is a little off topic, but let's say you own the water rights to like a stream on land.
Right.
Is it still illegal to put like a water wheel or something on it because you don't own the water rights to like every inch of the river, so someone downstream from you could do that. Is that the case? Do you know?
I don't know for sure. I mean, that's definitely more of a legal question, but I don't know because I've often had that. All our systems here work on gravity, basically. We don't really have anything pumped anywhere. And you look at all these irrigation canals going around. And I know of several people that have them running right through their yard. If I want to put in a small water wheel, am I actually taking anything out? I mean, I'm not taking, the only thing really I'm taking out of there is gravitational energy, right? I'm taking that kinetic energy of that water flowing by, capturing a little bit of it and converting it into electricity and powering my house. In the end, would my neighbor 100 yards down that irrigation ditch know the difference that I had that paddle wheel in there? No. So I don't know. That's one of those things I think legally in the court system, I don't think you could win that. I think, yeah, that would be against the law. Scientifically, I look at even if every person who lived along that irrigation ditch put in one of those paddle wheels, technically that water is probably gaining its energy back by the time it gets to the next paddle wheel. So you're kind of, because it's constantly renewing, are you really taking anything away? And I don't know. Scientifically, I say that's something that we should look into. Legally, I think you probably lose that battle. I don't know. That's something that I'm surprised we haven't seen in the courts, but we probably will. Box 512, and I find this one kind of interesting. A couple things about this. Hydroelectric projects in Brazil. Brazil, I don't know if any of you guys got to meet Thais. I know, Shauna, you did. She was an intern here last summer with us from Brazil. And Brazil, if they have one thing going for them, they got a lot of water. They got no shortage of water. And they use it to their full advantage. So they don't even kind of really look at solar PV or wind or anything because why bother? We just put in hydroelectric dams and power everything. Why even mess with it, And they don't have near the, I don't think, they probably have some version of the EPA, but I guarantee you they don't have any of the water restrictions that we do. They have no Clean Water Act or anything like that. So, but they do have an overabundance of that. But it's kind of cool that this hydroelectric plant, the Parana River between Brazil and Paraguay, started in 1975. Took them basically 30 years of building, so the last of its generators came online. Effective head of 200 meters, which is pretty impressive. That's a lot of energy stored right there. And average water flow at 10,000 tons a second. Supplies 95% of Paraguay's power and about a quarter of Brazil's power.
That's impressive.
That's very, very impressive. But I think, to me, the most fascinating thing that I saw about that is Paraguay runs at 50 hertz. Their grid runs at 50 hertz.
Oh, really?
Brazil runs at 60 hertz.
Oh, I see.
So, and it's making way, way more than what Paraguay can use for electricity. So even though everything is, the generators are producing AC current, the Paraguay side's at 50 hertz, the Brazil side is at 60 hertz, they have to rectify the Paraguay side back to DC and then reconvert it to AC at 60 hertz so they can use it. So literally, in the same room, I have two generators putting out different hertz. I have to take that one to DC and then back to AC so I can connect it to the generator sitting right next to it. So I thought that was kind of ironic. Average annual output of 91.1 terawatts. So average capacity factor 75%. So maybe they weren't too far off, but they originally contracted for 85%. That's why I thought that 50% was a little bit low in that other table we were looking at. Pretty impressive. And it might be the first power station ever to generate more than 100 terawatts in a single year.
From 2011, I wonder if it's.
Yeah, I'd be interested to look that up and see if maybe they've surpassed that by now. So even there, though, if you look at the other one, I'm going to try and, that tributary of the Amazon, they were going to put 6 large hydro plants, but once again, they kind of had the same issue we did. Like, hey, you put in a dam, you're going to flood all these indigenous people out of, where they live for forever. Talk about the annual flow and the rise and fall. Same thing we see here. In May we have a blowout and the Clark Fork is ripping through here, and probably 6 or 8 feet above normal. And then by the end of the summer, you can't float down without banging your butt on every single rock, between Bonner and Missoula. So there's quite a difference there, and they saw that they might have a capacity factor as low as 30%. Which really affects the overall return on investment. So it looks like they tried to work around it. So it started in 1975, June 11th, they were able to start working on it, to start building it. But they have to pay $1.9 billion to address social and environmental problems. So I'm guessing that probably they're spending, that's probably a fairly large percentage of what their total cost of what they're looking at is. I don't know what it cost to build 6 hydroelectric dams, but $1.9 billion is pretty substantial just for the social and environmental issues that they're dealing with. China has a lot of resources for it. Thankfully, they're moving away from coal and starting to do that. Let's see. Looking to see if they address that in here. They just built one that is the largest hydroelectric dam ever in the world. They have the same social concerns, environmental concerns, but I guess maybe they're kind of like we were 100 years ago. They're like, oh yeah, I know you live there, but too bad. Yeah, I saw that. I saw something on that where they paid them, the people that lived in these valleys that were farmers, they paid them the equivalent of like $60,000 for their land and everything, and for them to move. They all moved to the city. They had no idea what to do with $60,000. They blew it all in a couple of months, and now they have a huge homeless problem because those people's houses are underwater. They don't have the skills to live in an urban environment and nowhere to live, nowhere to go. So definitely a few issues there. So how many, this is as good for global, we'll get back to local again. How many hydroelectric dams do we have in Montana? Any guesses?
1, 2.
Large scale, I think we have 9. Is that the one that Northwest Energy just bought out? 9 or 10 of them, something like that. We have, it's fairly small numbers. It is probably about 10. But I was surprised that we have several hundred smaller hydroelectric dams. And I was supposed for them to meet the numbers, they're going to have to, or for them to get into that category, they're going to have a minimum, output that's substantial enough to actually affect the grid. So they're fairly well hidden that you don't realize that they're there. And I guess kind of going back to that before we get to the small scale, what have we seen the trend in the past 30 years for hydroelectric plants? We're not building more, but what else are we seeing? Any ideas? And this is mainly on the Columbia River, but also on the Snake River, the Salmon River. Salmon River might be a We're tearing them down. Our capacity has actually gone down over the past 30 years because of those environmental concerns, primarily over fish. But a lot of this stuff in the Northwest, once they saw how they were impacting fish runs and the fish ladders and the other bypass methods that they have for the fish are great in theory. For science, it's like, oh, well, you just jump up these boxes from one to the next, until you're past the dam and keep on going. Well, fish, unfortunately, are hard to train, and they don't follow those rules. So we've actually reached a point where in some areas we decide, okay, the value of having salmon or whatever that indigenous species is in that area is more important than the small amount of hydroelectric power we're going to get out of this plant. So we're going to tear it down. So you've seen a lot of them come out. There used to be a dam right there behind where they're building the new Missoula College, right? We jokingly talked to the architect, said, hey, what do you think about putting a little hydroelectric dam there just for our energy technology program? They didn't see the same humor in it that I did. I thought it was pretty funny, but no, they didn't. They weren't so impressed by that. So small scale hydro, we have quite a bit of that in Montana, and more, I think, than what you would realize. A lot of stuff that people don't think about. But what about the people that live way up in the mountains that have a little water wheel in the stream? I can tell you, if I had a cabin that had a little stream running through the property, there might be a piece of PVC pipe diverting some of that water through a water wheel and right back into the stream. I'm not going to hurt it any. I'm going to tell you that might happen, and there are probably a lot of people that feel the same way. So we don't really know about it, and it's weird how the different states vary. Alaska, they have a lot of those rural cabins. They have a stream going by. They have basically, it looks like a trolling motor on the end of a long pole with a counterweight. They go out there, and when they go out to their cabin, they dunk this thing down in the river and put a pin in it, and it just sits there and generates electricity the whole time they're there. They get ready to go home, they pull the pin, flip the counterweight down, so the propeller's just up waving around in the air, and they go home. So they have electricity when they need it. You wouldn't, I can't even imagine trying to get a permit like that to do the same thing on the Clark Fork River. But it all depends on the state and where you're at. So it is possible, and you do see that occasionally. All right, so we took a look at the overall hydro resource and how we use it, a little bit of the technologies of how we use it, how we harness it, and talked about the benefits and penalties. And it looks like, I think we've kind of come to a consensus here that while economically feasible, our biggest hurdles now are social and environmental. So it's kind of we have to figure out how we're going to balance that. And possibly when you can't heat your house with coal anymore, or you can't heat your house with fossil fuel, it might come back, and we might see a resurgence of what people are willing to give up in order to have heat and electricity. Until then, we're kind of still stuck. We were just talking about in 101, the convenience of oil, the convenience of fossil fuels in general. Until we get over that convenience, probably not going to see a whole lot of growth in hydroelectricity. So any questions or comments on that before we move on to tidal power?